In this video, we are going to look at the sign convention for various quantities while solving the numerical problems for spherical mirrors. All of us know about the Cartesian plane, where horizontal axis is the x-axis denoted by x dash, vertical axis is the y-axis denoted by y dash, and the point of intersection is origin. All the x coordinates to the right of the origin are positive, to the left of the origin are negative. All the y coordinates above the origin are positive and below the origin are negative. So we will use a similar sign system to various quantities in case of spherical mirrors. So here the pole will act as origin. So all the distances above the pole will be positive. All the distances below the pole will be negative. All the distances to the right of the pole will be positive. All the distances to the left of the pole will be negative. Here we assume that light is incident from the left of the mirror. Incident light. So note down all the distances above the principal axis are positive. Above the principal axis are positive. And what will be the corresponding corresponding statement? All the distances below the principal axis are negative. Below the principal axis are negative. So all the distances above the principal axis positive, below the principal axis negative. The point of reference is the pole of the mirror, which is the center of the reflecting surface. Now let us consider the left of the mirror and right of the mirror. Now to the right of the mirror, we will have the positive x coordinates. So all the distances to the right of the mirror will be positive. All the distances to the right of the mirror are positive, and corresponding statement will be all the distances to the left of the mirror are negative. So right of the mirror positive, left of the mirror negative. Above the principal axis positive, below the principal axis negative. So using this, we will solve numerical problems. Now while numerical problems are presented, we will need some formulae for calculations. So let us look at them. Let us look at the formulae which will help us in solving numerical problems regarding spherical mirrors. So the first formula is mirror formula. Mirror formula, it is 1 upon V plus 1 upon U is equal to 1 upon F. Now in this chapter, we know that F is the focal length of the mirror, but we still do not know about V and U. So let us see what these symbols represent. So F is the focal length U is the object distance and V is the image distance. Now for concave and convex mirror, the focus is either in front of the mirror or behind the mirror. Front of the mirror means to the left of the mirror. Behind the mirror means to the right of the mirror. And we have just seen that distances to the left of the mirror are negative and distances to the right of the mirror are positive. So what will be the focal length in case of concave mirror? Because focus is in front of the mirror, the distance fp, the focal length, will be negative. So focal length of concave mirror is negative. Focal length of concave mirror is negative. Now what about convex mirror? Here focus is behind the mirror. So the focal length will be positive. Focal length of convex mirror is positive. So always for a concave mirror, focal length will be negative. For a convex mirror, focal length will be positive. What about the image distance? Image distance. So images are either formed in front of the mirror or behind the mirror. Now, if image is formed in front of the mirror, we call such image real image. So here image distance will be negative as the image is to the left of the mirror. So image distance for real image is negative because real images are formed in front of the mirror. So distance will be negative. What will be the image distance for virtual image? Virtual images are formed behind the mirror. So to the right of the mirror, hence those distances will be positive. Image distance for virtual image is positive. Image distance for virtual image is positive. Now that leaves us with object distance u. Object is always kept in front of the mirror. That is, object will be always to the left of the mirror, and distances to the left of the mirror are, yes, always negative. So object distance is always negative. Object distance is always negative. So let us recap. Mirror formula is 1 upon V plus 1 upon U is equal to 1 upon F. F is the focal length, U is the object distance, V is the image distance. All these distances are calculated from the pole of the mirror. They are calculated from the pole P of the mirror. Now for a concave mirror, focus is in front of the mirror, that is to the left of the mirror, hence focal length is negative. For a convex mirror, focus is to the right of the mirror, so focal length is positive. For a real image is formed in front of the mirror, that is to the left of the mirror, hence image distance is negative. For a virtual image which is formed behind the mirror, as the image is to the right of the mirror, image distance will be positive. And in case of object, always object is kept in front of the mirror, that is to the left of the mirror, hence object distance is always negative. Another formula we need to know is of the magnification. First, we need to understand what is magnification. So, magnification is basically the comparison between the size of the image and size of the object. So, magnification M is equal to height of the image divided by height of the object. So, we compare the heights of image and object. Now, height of the image is denoted by symbol h2 and height of the object is denoted by symbol h1. So, we get magnification is equal to h2 upon h1. It can also be proved that magnification is equal to minus v upon u. That is magnification in terms of v, which is the image distance, and u, which is the object distance. So, this is also an extremely important formula to calculate magnification. h2 is height of the image, h1 is height of the object, and v and u, as you know, are image distance and object distance. Now, real images are always inverted, that is upside down. They form below the principal axis. We have studied in sign convention that distances below the principal axis are negative. So, what will be height of a real image? It will always be negative. Similarly, virtual images are always erect, that is above the principal axis, and distances above the principal axis are always positive. Hence, what will be height of a virtual image? It will be positive. So, let us write it down. Height of real image is negative. Height of real image is negative. If you recall, image distance is also negative, and height of virtual image is positive. Similarly, image distance of a virtual image is also positive. What about the object? Object is always kept upright above the principal axis. Hence, height of object is positive. Height of object is positive. Now, important thing you should always remember is while substituting the values in the formula, be it the mirror formula or the magnification formula, you should always substitute the values along with their respective signs. If the value is, let's say, plus 3, substitute plus 3. If the value is minus 7, substitute minus 7. That is of the utmost importance. Substitute the values into the formula along with their respective signs. And what should you use as a reference for signs? The Cartesian system, which we have looked at the beginning of this video.